Okay, so I didn't do an example that had this particular trick in it. Did anybody figure out what the first step needed to be in 15? Would you just it does have to do with Pythagorean. Yeah. But not with cosecant. Maybe you could do it that way. Let me show you what the first step is and see if you can figure out how I got this. What did I do there? I did a little factoring. I factored a common factor. Both of those terms had a cosine in it, so I pulled that cosine out in front. The same way you would factor a GCF. And then from here, this is looking a lot like that first Pythagorean identity, isn't it? And can I get everyone's attention? This is going to be important because I'm going to release you from a little bit of work here. Okay. So yeah, you want to pay attention to this. From this moment on, I give you permission to modify any of these Pythagorean identities by moving terms to the other side of the equation. Okay. So I need you to know that sine squared plus cosine squared is equal to 1, but you are now allowed to, for example, subtract cosine squared from both sides and make a new identity that says sine squared equals 1 minus cosine squared. Okay. Are we okay with that? So you don't have to use it exactly in this format. You're free to move things around. So like you could make this identity say tangent squared equals what? Tangent squared equals secant squared minus 1. Okay. And then any place you see a tangent squared, you could replace it with secant squared minus 1, or vice versa. If you found a secant squared minus 1, you could replace it with the tangent squared. So when I see this, I see 1 minus cosine squared. What is 1 minus cosine squared equal to? If I brought this over, that is equal to sine squared, isn't it? So that would be my next step. So I've got cosine x, sine squared x, and I don't think we're going to be able to go any further than that. Okay. What was next? 23. All right. As soon as I see pi over 2 minus x, I start thinking of cofunctions. So I know that this is going to be a cofunction identity right here. I'm going to go ahead and do that first. The cofunction for tangent is cotangent. And when you change it from its cofunction or its function to its cofunction, you basically lose the pi over 2 minus. So this is going to just be cotangent x. We still have cosecant x over cosecant squared x. The first time I did this, I jumped right on that and didn't even realize until I was writing down that first step that, oh my gosh, I got a cosecants on the top and bottom of that fraction that I can factor, or I'm sorry, that I can cancel. I got one here and more than one down here. So if I canceled one from the top, one from the bottom, we'd end up with cotangent x over cosecant x. Something tells me we're going to be able to go a little bit further than that. I find sometimes when I'm dealing with fractions that are things that are not sines or cosine, rather than write this as a fraction, sometimes it helps me to rewrite it a fraction in this format. Do you see what I'm doing there? So because when I write it this way, then I can be like, oh, this is, what is 1 over cosecant? That's 1 over cosecant is sine. Yeah, that's a sine. So instead of having division by cosecant, I'm writing it as multiplication times the reciprocal of cosecant, and that turns into sine. So now I got cotangent x times sine x, and then I'm going to turn cotangent into a fraction, and I'll let you finish the last couple steps there. That should get you towards the finish. So remember this little trick. If you end up with a fraction and it's got something other than sines or cosine, try writing it instead of as division, writing as multiplication by a reciprocal. A lot of times that's going to get you Get you where you need to be. Okay, 16. This didn't jump out at me right away. It took me a minute to realize that we do have sine squared and cosine squared in that numerator. They're not right next to each other, but they're both up there and they are being added together. What is sine squared plus cosine squared? 1. So I'm going to rewrite it with a 1 in place of the sine squared and cosine squared. The tangent squared is still there. And I feel like 1 plus tangent squared is one of our identities also, isn't it? 1 plus tangent squared is secant squared. I'll let you finish that one up as well. So they were kind of tricky in this one about the sine squared and cosine squared. They separated them, right? Sorry. Yes, yeah, exactly. And 24. Sure, about that one. Okay. So you did 1 over secant x plus tan squared over secant x.
Yeah.
What do you mean you split it, the tan? Okay. Tan squared secant minus 1. Can I look at it? Let me look at your. Grab my sheet here. So from here, here's 1 secant plus 1 secant minus 1. I'm not sure where this is coming from.
Yeah,
Oh, it's because tangent squared is equal to secant squared minus 1. This does work. 1 over secant. 2. Where's the 2 coming from?
I think that might have come from the ones.
But it would be 2 over. Well, the ones are going to cancel. It's a positive. That's a negative. I'm up to here. I think you're good. I think you probably need another step in between here where this tangent squared turns into 1 minus secant squared to make that a little bit clearer. But I'm not too sure about going past there. It ends up, the correct answer ends up being secant x, or 1 over cosine if you prefer. Okay, going on to 24. There are probably other ways to do this, but the only way I've been successful at it so far is turning tangent into sine over cosine, turning cotangent into cosine over sine. So that's going to be my first move here. And then I got to here and I was like, this is getting to be a mess because I have addition, I got fractions inside of fractions. How do we unmess this? My next idea was that on both on the top and bottom, I'm going to get a common denominator so I can add these two things together. So I'm going to rewrite this. I'm leaving the ones out. We're going to replace them with something. Right, those are ones. I'm going to come up with a fancy version of 1 that's going to be convenient for me because it'll have a common denominator with this fraction here. What's that fancy version of 1 going to be? It's going to be cosine x over cosine x. That will have a common denominator with this, and then I can combine them together. Cosine x over cosine x. And the other one that was on the bottom, I'll replace this with a fancy version of 1 that's going to be convenient for me to combine with this fraction, which would be sin x over sin x. Now I got common denominators on the top and bottom. So here's my big fraction bar. I've got I'm going to be able to add those together and make a single fraction on the top and on the bottom. On the top, I've got cosine x plus sine x with a common denominator of cosine x in both of them. On the bottom, I've got sine x plus cosine x with a common denominator of sine x. This is getting nasty, but at least now I don't have addition and fractions inside of my fractions. And then for me, the key to finishing this off was to rewrite this kind of like I was telling you before. Instead of dividing by this fraction, let's turn it into this fraction multiplied by the reciprocal of this. All right, so instead of dividing, so I'm going to keep that top fraction. But instead of dividing by this fraction, I will multiply by the reciprocal of that fraction, which is sine x over sine x plus cosine x. I got a couple of factors here that match perfectly and are going to cancel out. So I'll end up with just sine x over cosine x, which is tangent. That one got a little messy. Did anybody come to tangent for that in a friendlier way? How did you do it? I'm just curious.
How that 1 plus tangent was
1 plus tangent squared is equal to secant squared. Okay. Okay, interesting. We got to be careful about that though, right? So 1 plus tangent, 1 plus tangent squared is equal to secant squared, but you can't just square root everything. It would be nice if you could. It's like the one thing that I wish was true in math. Right? Did you know that if you did like 9 plus 25, you can't just take the square root of that whole thing and get the, it's not gonna end up being 3 plus 5. Unfortunately, it'd be nice. That's not. Yeah. Cosine x plus sine x is not equal to 1. Cosine squared x plus sine squared x is equal to 1. Okay, so and that's, so we're having people, can you guys do your side conversation some other time? Yeah, so and that's going to happen sometimes when you can do something like an illegal move like that and you still end up with the right answer, but not always. So yeah, we can't with our, and this is a common thing, and I wish maybe this problem wasn't in here this early, because you can't just remove the squares on any of these Pythagorean identities. They don't work that way, except for every now and then when it does still work out. All right, let's get on to the business of today, which is proofs. And I put these strategies up on the board a moment ago. I'll stick them here while I'm switching the video over.